Hi, this is Sky Perry with SSP Innovations, and I'm here today to talk you through some of the out-of-the-box tracing functionality we have in the new utility network based on the electric tracing for circuits. Now we're going to start off by taking a quick look at the circuits we're seeing on the screen. Now we see two circuits, a red and an orange one, and as I click on these to identify them, I want you to note that this is RMT003, but more importantly, this is an individual single feature on the map as I flash that record on the map. So it's a single line, a single feature representing the entire circuit. Now on the south side, as I go and select RMT001, note that this is also a single circuit. So really, for these two circuit extents, I'm showing a single feature each, and this is automatically generated by the utility network into the subnet line feature class. Now this is key, it happens out of the box, it's nothing we have to do, but it does make color by circuits or color by systems very easy to make, and also easy and fast to display, whether it be on the desktop or via your web applications, because we're rendering only a single feature per individual circuit. So with that, let's go ahead and dig into some of the more detailed tracing functionality we have available. I'm going to zoom in here to the north substation. So with that, I'm going to go ahead and select the breaker in the substation to begin our first trace. And specifically, we're going to trace off of the load side. A breaker has two terminals, a source and load, and we're of course tracing downstream, so we want to choose the load side. Next, we'll go ahead and choose the SSP full circuit trace. This is simply an out-of-the-box configuration utilizing Esri underlying traces. And we're going to go ahead and run that. Now you see the selection of features come back on the screen, and we can then zoom to the full extent of that trace. And you can see it matches the RMT003 one line we just saw previously, tying into the south circuit at the two tie switches as indicated here on the map. Now to prove that out, let's go ahead and do the same trace based on the south substation. This should light up the opposite. We'll once again come with trace locations. We will clear our existing and add a new. We'll grab this circuit breaker here and once again choose the load side. With that, we can simply just run the existing trace one more time. And you can see the return records shown as highlighted on the map. We'll again zoom to the full extent. And you can see that here, and again, it's tying in at the same locations, those two tie switches there into the northernmost RMT003 circuit. So that works very well, tracing the entire circuit. Let's get into some more detail. And for that, we're going to go ahead and zoom into a more local area here where we can see some service points. So from this service point, we're now going to identify that as our trace location. And from this location on the map, we're going to go ahead and run a upstream trace. This trace executes and returns a selection. We'll once again zoom to the extent of that selection, and you can now see the full extent of that trace from the location here on the left, all the way back down south, heading out eastbound, all the way back to the north substation. Now for this next trace, we're going to run the exact same component. However, we're going to run a separate trace. I say trace from the same location, but run a different trace. We're going to run the SSP Upstream Protected Device trace. Again, just configuration off out of the box. We're going to run this trace. Main difference here is we're no longer tracing lines. We are only tracing specifically the protected devices as defined within the utility network. So you can kind of see the various fuses and switches selected on the machine, but to show that a little bit more clearly, I'll flip over to the attributes. So we can see the breaker, which is located here in the substation. Maybe hard to see it flashing. We have a number of fuses. And of course, we have a number of switches. So again, that worked very well to identify that specific trace location. Now finally, let's zoom back to a similar location. And we're going to do a downstream trace. So in this case, we'll go ahead and grab the trace location of this transformer. And we're going to trace the low side of that transformer. And there we'll go ahead and run a downstream trace. And this trace results out and shows us a number of downstream features. If we zoom to results, we can see the extent of that trace all the way out to the service points. Our final trace might be to go to a tap location within the network to select a trace locations, and just to note that we can select a point or a line. So we can go grab this line here on the map. And from that line, we can go ahead and do a downstream protected device trace, very similar to the upstream, other than now we're going downstream. Once again, we can see the entire extent of the trace, and included in this We only have a handful of switches, 2 switches to be exact, and 3 fuses. So what if we wanted to include the structures in the trace? So we'll run the same or a similar downstream trace from that location. And this time we will check the Include Structures checkbox. We'll go ahead and click the Run button. You can see the results there on the map. The key change with this trace is that as we go to Attributes, we of course have our transformers, our elbows, fuses, service points, etc. But we now also have pads, and again these would be pads defined as structures, and we could zoom to an individual one of those. And we also have poles. So there is no additional work required to be performed, no customization. We're able to trace out and return the structures based on any trace we perform within the utility network. You've seen those options on all the traces I've performed here today. So very simply, we can include the structures because they are in the network within any trace results. The final piece of information that I'd like to show you is just that the individual components in these traces, let's just take the transformers for example, are also maintaining the circuit name, in this case, RMT003, is maintained as an attribute. And notice that's a read-only attribute. That is because the utility network is also maintaining that circuit name directly on my features. This has just been a brief overview of the circuit tracing and circuit functionality within the utility network. Stay tuned for more.